So hello everyone and welcome to this week's edition of Armagh Astrobytes, where we take astronomy and break it down into bite-sized chunks. We're back again with Planetarium Director Michael Burton, and today we're going to talk about how stars are born. So, first question for you. What is star formation?
So Courtney, this beautiful picture here kind of summarizes star formation. We see in the top right-hand corner a dark cloud of gas and dust. And the bottom left-hand corner, we see a young star cluster, all those bright bluish stars you can see here. And essentially, star formation is taking a cloud of gas and dust and turning it into a cluster of stars.
So how does star formation actually take place?
Well, this is a very interesting question, and it's been challenging astronomers for many, many years. This sketch here outlines how we think the process takes place. Essentially, we go from on the top left here, a dark cloud of gas, and on the bottom right, we end up with a stellar system of a star surrounded by a planetary disk, in fact, with planets in it. There's a number of stages. The key part, though, is that the cloud collapses under the weight of its own gravity. It's called gravitational collapse. A disk of material forms around a forming protostar. The disk is rotating, and then a jet of matter is ejected from the poles that starts to clear out the disk. And then from the disk, the planets form, and from the remnants that fall back into the star is born itself. So we've got a six-stage process of star formation.
Can we actually see stars forming?
Well, that's the next question. So astronomers have built up this picture through observing the process of star formation and understanding it takes place in many stages. So the best place to start this journey of discovery, in fact, is to go to one of the nearest star formation regions to us. It's in the Orion Nebula, which you can actually see with your naked eye. It's that faint fuzzy patch just below the belt of Orion, and there's a big gaseous cloud over there. And inside that cloud, we now know there's hundreds of stars which are actually forming.
So where are the baby stars?
So if we start to look closely into this cloud, and we use telescopes like the Hubble Space Telescope, or sometimes we go to new wavelengths like infrared telescopes, which let us look into the clouds of gas and dust, and we can pick out some of the young stars. So the image is dominated by the bright stars there, but in fact, there's actually hundreds of stars. And some of those stars, the ones that are outlined in this picture over here, we see are actually surrounded by these disks of material. You can see the sort of dark silhouette. And that we now realize is actually this proto-planetary disk in formation around a young star in the center of that disk.
Okay, and what happens next then?
So essentially what's going on is that the material essentially falls under gravity to the disk, and the disk, it rotates around there, and some of that material actually then accretes into the center. That's the young forming protostar. But as part of that process, we also have to have a jet of material shot out from the polar direction. That actually helps clear the disk and also helps our material fall down into the center. And we can actually see evidence of this in process. This picture here, another beautiful Hubble Space Telescope image, shows in a disk of a jet around a system called HH30, Herbig-Haro 30. We can't actually see the central star. The central star, in fact, is hidden inside a dust lane over here. But this green color is actually reflected starlight actually off dust grains which are above and below the disk. And the red color is this jet which is being shot out over here. And the entire scale of this picture here is about the scale of our solar system itself. This bar down the bottom shows something about the size of our solar system, including the Kuiper belt and the cometary system, way beyond the orbits of Neptune and Uranus. But this is the evidence of what's going on.
Speaking of our solar system, can you see planets forming?
We can't see in that last picture, but in fact, some of the latest and newest telescopes are allowing us to start to see the process of planetary formation. So I've now turned to a beautiful image produced by the Armagh Radio Telescope, a great big new radio telescope in the highlands of Chile, the outer planar of Chile. And this picture here actually shows a protoplanetary disk in formation around a star called HL Tau. We see the disk-like structure, and in particular, what we can see is these gaps between the rings, and we believe inside these gaps is actually where a planet is forming. In this case, a rather large planet, perhaps the mass of Saturn or so, and it's sweeping up material, and that is going into to form the planet. And in the center, the star, much of the material actually it collapses in under gravity to the center, and that's where the young star is forming itself.
Right. And how do astronomers know what's going to happen?
So that's another very good question, because this actually is very challenging to understand. So it's a combination of observations like I've been showing, which break up a series of stages, and then modeling, numerical modeling, putting our best efforts into computer codes to try and calculate what goes on. So essentially the idea is that we now can model through our computers the collapse of a cloud into a disk. In the central parts, where the planets are forming, the radiation of the star kind of blows away all the light gases, and we get left with the rocky planets, the planets like end up being like our Earth. But in the outer part of the disk, where it isn't so there isn't so much energy from the young star, the gases are left, and we end up getting these large planets. The planets a bit like Jupiter and Saturn, for instance. So we can start to model this numerically now with our best computers.
Wow. And do we think this is how our own solar system formed?
Indeed, we think this is the process that goes on. A key part of this is the fact that we've got, and a very challenging part to understand, is that these dust grains have got to stick together. So I've actually just shown a picture of a particle of interplanetary dust, which is picked up in our solar system, but the sticking together of these particles, growing, accumulating in size as they collide. This is a key part of the process. We don't fully understand how it occurs, but indeed it involves the sticking together of particles of dust and them coming together under the weight of their own gravity, and we do end up with planetary systems in formation.
Wow. So not only did we learn about how stars are born, but this is also how we learn about how planets and solar systems are born as well.
Well, yes, essentially that's right. Planets are the debris left over from the formation of a star. Essentially our Earth and all our planets are the debris which didn't actually end up going into our sun. And eventually it probably takes 100 million years or so for this process to work its way through for a system like our own solar system. We end up with a central star, which has got sort of 99.99% of the matter. But the debris left over is very interesting because it's planets and places where we indeed came from.
Lucky for us that there was some debris left over.
That's right, we're the debris from star formation. When you look at it that way, we realize the scale of the universe and how small we actually are.
So that is the last question I have for you today, Michael. Thank you for explaining about how stars are made, and not only that, but how planets and how our solar system may have been made as well. So I'd like to thank you for coming along to this week's Astrobytes, and thank you for everyone for watching.